Hello and welcome to episode 2 of All Things in Modulation, where we are continuing to look at how to make a software synthesizer in Max MSP. Now, in the first video, this is where we got up to. We've got a patch here which just makes random beeping noises. And the way it does that is that we've got some oscillators which can produce a note at a given frequency. And we are sending those oscillators MIDI note numbers. And these numbers from 0 to 127 each correspond to a note or frequency that the oscillator can play. And in this patch, we're just generating those at random. But the next step is to look at how we could choose which note to play using something like this, a MIDI controller keyboard. You might have one of these lying around at home, which you can connect to your computer. But if not, don't worry, because you can just use this type of keyboard, a standard computer keyboard. So we're going to have a look at how we could get something like this to do what this does. Alright, so the first thing that I'm going to do is to get rid of anything in this patch which is unnecessary. So all of these kind of duplicates here of this bit of the patch, I'm just going to get rid of those. I don't need them. And I don't need this bit here that generates the MIDI note number because we're going to do that using a keyboard. So what I've got is the MIDI note number, the oscillator, the gain control, and then the audio output. By the way, if you want to change your audio output, you can do that by going to Options, Audio Status, and from there you can change the output. So in other words, where the sound is going. You might want to go to your headphones, speakers, or whatever you're using. So I've got my little MIDI controller keyboard plugged in. This is just a very cheap one, and it connects by USB. And then if I make a new object called Note In, Receive MIDI Note Messages, I can see the messages that this keyboard sends into my computer. So we've got 3 outlets here: pitch, velocity, and MIDI channel. We're mainly interested in these 2 here, pitch and velocity. So if I make a new number box, I, for an integer, and then connect these up to that object, and then I press a key on the keyboard, I can see I've got a pitch there on the left, so that corresponds to the note that I'm playing, which key I press. And then on the right, we've got the velocity. Now that corresponds to how hard I've pressed the key. So whether I've pressed it very hard or whether I've pressed it very lightly, the number will change. And then that number is used to control how loud the note is played. And notice also when I let go of the key, so I'm holding the key down now, and then I let go, it goes to 0. Okay, so a 0 means that we don't hear that note, and then any number greater than 0 will play the note, but with that level of loudness. So that's what we've got if we've got a MIDI keyboard connected. But as we said, you might not have one of these at home. You might just have a computer keyboard to use. So let's look at how we can get to this point here using a computer keyboard. What are the similarities and what are the differences? Well, a computer keyboard, when you press one of the keys, will output a number, just like the MIDI controller keyboard does when you press one of its keys. The main difference is that we've got no control over velocity. We've either pressed the key or we've not. It doesn't matter how hard we press the key. So we're not going to be able to control loudness using a computer keyboard. So in order to see those values, we're going to make a new object called key. Report keyboard presses. And the left outlet gives us the ASCII code of a key pressed. So make a new number box, connect that up, and then if we lock the patch and press some keys, we'll see that there's a different number for each one. If you look at the layout of the keys on a piano keyboard, you've got all the white keys in a row next to each other. So C, D, E, F, G, A, B, and then back to C again. And that's called an octave. So from C to C, for example. So you've got all the white keys in a row, and then in between some of the white keys, you've got a black key. So between C and D, there's a black key. Between D and E, there's a black key. There isn't one between E and F. And then between F and G, there's a black key. Between G and A, between A and B, and then there isn't one between B and C. And altogether, that makes 12 notes, 12 different keys in an octave. And if you look, it's the same pattern again and again. So 2, 3, 2, 3. So there is a repeating pattern to a piano keyboard. What we need to do is take a computer keyboard and make the same pattern. So a good place to start for this is from A, and then just move in a row across. So I'm just gonna, just for display purposes, I'm going to make a little square, a little white square, just to mark the keys that would be our white keys. So make the interior of that white. Okay, so we're going to start off with A, so just to the right of the caps lock. So we're going to have A, and then S, D, F, G, and then we'll keep going. This picture only goes up to there, but you would keep going along your keyboard. So if you had some stickers, you could stick some stickers on the keyboard. So starting from A, that's going to be our C. We're going to go along, and it's going to be all the white notes next to each other. And then we need the black notes. So we're going to start there. So if you look, it's diagonally and up from C. There is a black key. I'm just going to make that black. There we go. And then there would be another one there. Okay. And then between E and F, between these two keys here, so that's here, it misses a black key. There isn't one there. And then we've got 3 of them. And so on. So that's the pattern that we're going to follow. So what we need to do here is to build up a list of the ASCII codes for each of the keys that we're going to use from the computer keyboard. So what I need to do is to get another message and send a message to this message to say append this value to a list. So if I said append 97 and then I click that message, it will add 97 to this message, and it will keep doing it, or anything else that I want to add to this list. Now, I don't want to keep typing this in. The point is that I want to build up the list just by pressing the keys on my keyboard. So what I need to do is to say append a variable. So the value that I am appending to this list is variable. It will change every time. It will change when I press the key. And the symbol for a variable is $. And then you just have a number. So if I had 2 variables, they will be numbered 1 and 2, and so on. So if I connect that up, and then lock the patch, and all I need to do now is to press the keys I want to use. So you just need to make sure you press in the right ones. So if you need to go back and check the diagram that we just made on a keyboard, you could do that. Or if you wanted to put stickers on the keys or something to help you out. But I'm also just going to say them. So we're going to start off with A, and then we've got W, S, E, D, and then it's going to miss out the next diagonal. So the next one will be F, then T, G, Y, H, U, J, miss out the next diagonal, K, O, L, P, colon, apostrophe, square bracket, hash key. Now, depending upon the kind of keyboard you've got, the symbols might be different, the ASCII codes might be slightly different, but as long as you're following that same pattern. So we've got a row of keys from A, they're like our white keys, and then for the black keys, you're following this pattern of 2, miss 1 out, 3, miss 1 out, 2, miss 1 out, 3, miss 1 out, to get something that looks like a keyboard. Alright, so now that I've done that, I'm just going to delete this to make sure I'm not adding any more to this list by accident, and I just need to check that that's the complete list. So I started at 97, I might have just added an extra one to it then. 92 is where it should end. Yeah, it looks like I've added some extra keys to this, so obviously I pressed a couple of keys to do some other things after I'd finished adding to the list, and I guess that's added those values, so I'm just going to take them out. So that is now my list of key values. To replicate this as closely as possible, when each key is pressed on the keyboard, I want it to bring with it a kind of a velocity value, a sort of an on or an off value. I'm going to make a new message, and then we're going to say, let's take this variable and add to it 127. So we're going to append 127 to that variable. So every time we press a key, we get that number of the ASCII code of the key we've pressed, and we get the value 127. So now we've got this list of numbers, which are the ASCII codes of the keys, which we're going to press on the computer keyboard. And now we need those to correspond to MIDI note numbers. So what we can do is make a new object called root select outlet based on input matching. And each one of these numbers here is going to have a different outlet. So if we copy this list and then paste it into root, and now we've got an outlet for each one of these numbers: 97, 119, 115, and so on. So now we're finished with that, we can get rid of it. Connect that up to the first inlet. So these values are going to go into here, the ASCII code that we pressed, and also this value 127, which is kind of like our on value. And depending upon the ASCII code, it's going to be carried to one of these outlets. So just to have some bangs to show how this works, if I connect up just the first few, if I press A, it will be the first one. There we go. W is the second one. S is the third one, and so on. So what's going to happen here is that the rest of the packet is going to pass out of the corresponding outlet. So if I press the key A, which is 97, that 127, which I have paired with it, is going to pass out of that outlet. So I would like a message that says, well, let's keep that value, but before it, let's put the value 0. And that's going to correspond to a MIDI note number. And then we're going to need a bunch of these in a row. So I'm just going to copy, and then if you hold down Shift and use the arrow keys, you can move like this. It moves, instead of by one pixel or by one small amount, it moves by a larger amount. So it's quite easy to arrange objects tidily in your patch if you do that. So what I'm going to do, I can't remember exactly how many I've got, but I'm just going to make something like the pattern that I would have on my keyboard. So it was, if you remember the pattern of the black keys, you have 2 here, miss one out, then 3, miss one out, and then 2, miss one out. And then that was how many keys I'm able to fit on my computer keyboard. So I might as well make all of these ones on the bottom row white and make the ones on the top row black. And then I should also change the text color there just so that it stands out. There we go. Okay, so what we're going to need to do now is to have the numbers go up with each message. So this one's 0, the next one will be 1. Oops. Next one is 2, 3, and so on. So just going up, numbering each of these. And then this takes a while to do. There's not really a shortcut for doing this, but just need to connect all of these up. So just to make sure I don't miss any out. Okay, and if you've done this right, you'll have one spare outlet at the end. So what you always get with this object is that you get an outlet for each of the values that you've given. So all the way up to 92. And then the last one is if the input value doesn't match. So there's always a spare outlet at the end. And so now we've got a packet of values here. We've got like a MIDI note number, just starting from 0 and counting up. And then we've got this variable here, which is 127. And we need to separate those because when we press a key on our MIDI keyboard, we get the pitch, we get the MIDI note number, and then we get the velocity value. So we get two separate numbers. What we need to do is separate these out. So to do that, we can make an object called unpack, and it's going to be unpack I. So we're unpacking two integers, and they're going to pass out of these outlets here. So when we connect this up, there's a bit of a shortcut here. If you hold down Shift, you can just connect to multiple places like this. Saves a bit of time. And then just get rid of your last one. There we go. Okay, so let's make two number boxes. So I. Try pressing our keys. There we go. So what we're trying to do here, the whole point of this, is to use the computer keyboard like a MIDI keyboard. So we want kind of the same thing as we've got here. So this is my MIDI keyboard on the left. If I press a key, I get the MIDI note number and the velocity value. And on my computer keyboard, I press a key, I get this velocity value. That's not going to change. That's just going to be 127. So we're not going to have any variable velocity values. It's just going to be 127 or 0. And we get a MIDI note number. Now, I've just started from 0. So what I can do is just add to that number. So for example, I've just pressed this key here, which is a C on my MIDI keyboard, and it gave me the note number 60. So let's just add 60 to these numbers here. And now, there we go. So I've pressed that key there, the key A on my computer keyboard, but it actually corresponds to the note C, and it's given me 60 and 127. And then the next one will be 61, 62, 63, and so on. With the MIDI keyboard, I get a velocity value when I press the key, and then when I let go, I get a 0. So this is what's called a note on and a note off. It's like key is pressed down and key is released. So I need that same thing here. So in order to do that, I need to report when the key is lifted. So this only reports when the key is pressed down. To report when the key is lifted up, I need another object called key up. So record key information on release. It basically does the exact same thing as this object, except instead of it being when the key is pressed, it's when the key is released. Okay, so press the key, release the key. So what we can do is to use that information to send a 0. So instead of 127, we'll send a 0. And it can just go into here. And now, first of all, check on our MIDI keyboard. So I've got the note here, 60. Press that. 60, velocity value, and then releasing the key. There we go. And then try it on our computer keyboard. So I'm going to press the key A. 60. We've got a velocity value, and then I release the key. If you want to tidy all these patch cables up a little bit, because it can look a bit untidy when you've got so many of them like this, what you could do is if you hold down Alt and then highlight them all, so Alt and then Shift and Alt and highlight all these, and then if you go to Object and then hide on lock, that will actually hide all of those patch cables whenever you lock the patch. So that can help to tidy the appearance a bit. Okay, so to test this out, we could just connect this up to our oscillator. So these are MIDI note numbers. We could connect that up to here. We don't need this one. And then these MIDI note numbers, they're going to be converted to a frequency, and that's going to control the oscillator. So let's turn up the gain. we go. And of course, if you've got a MIDI keyboard, it's just a matter of connecting this up to the MIDI note value on your MIDI keyboard. So I'm just going to rearrange things a little bit to make some space. I'm going to resize this and make it horizontal, my gain control. And then this is going to go down to the bottom of my patch. As I say, if you've got a MIDI controller keyboard, you can just use this as your pitch and velocity input. But because I'm expecting that most people wouldn't have one and would have used their computer keyboard to do this, I'm just going to carry on with this part of the patch. So I'm going to connect that up. The next thing that we need is to have our velocity value controlling the volume of this oscillator. So at the moment, we can change the pitch of the oscillator. But we can't actually turn the note off. We can just change the pitch. So what we want to do is to have this control the volume of the oscillator. So what we need is a separate volume control between the oscillator and our master gain control. So I am going to cut this patch cable. And then after the oscillator, what we're going to need is an object to control amplitude. So if you make a new object and then type in asterisk, so a multiplication symbol, and then the symbol for signal, so tilde. So this object allows you to multiply two signals together, but it can be used as an amplitude control. So if I run my signal into the left inlet and connect that up to my gain control and turn this back up again, nothing's coming through at the moment, but if I send a positive value to the right inlet, then the amplitude will increase. Now you've got to be careful with this. Notice that I'm using a float object here, so that's got a decimal point in it, and I am dragging from the right hand side of the object, and that allows me to increase or decrease by a small amount. What you don't want to do is go like this and drag it up to a really high number, because that's then going to make a really loud noise and it's going to distort. So we don't want to do that. What we need is for this value here to control our amplitude. Now, I've just matched this to velocity. So what we've got when we press a key is 127. Now, to control this amplitude control here, what we need is a range of values between 0 and 1. So what we could do is to take this value here and divide it by 127, because then that's going to turn 127 into 1. Now you might say, well, what's the point in having 127 here in the first place? Why not just have a 1 to start with? Now the point of this is that we're trying to replicate what a MIDI keyboard does. MIDI note numbers and control change numbers are always 0 to 127. That's the range of numbers that is used. So to replicate that, to imitate what a MIDI keyboard does, we've used the value 127. But in order to control amplitude, that needs to be between 0 and 1. So now we've got So now, whenever we press a key, as well as controlling the pitch, we can turn the note on and off. So I'm pressing a key now, and that plays a note, and then when I release it, the note stops. As you can hear though, it's a little bit clicky. So we get this kind of like clicking noise. That's because we're jumping between amplitude values without ramping between them. So we're immediately jumping from 0 to 1 or 1 to 0. And that causes like a clicking sound. So we need to ramp between these values. We can't just go from 0 to 1 immediately. We need a ramp. And a good way of doing that is to use what's called an ADSR envelope. Now, envelope basically just means transition between states. And ADSR is an acronym. It stands for attack, decay, sustain, release. So to help visualize that, I'm going to use an object called function, breakpoint function editor, and it's kind of like a graph object. And this is going to help us to visualize what an ADSR envelope actually looks like. So first of all, we've got the attack. Now, if we're talking about an ADSR envelope controlling amplitude, so the volume of a note, that note could immediately start, so it could just go from 0 to 1 straight away, or it could fade in, so it could go like, and that's called the attack. So the amount of time that we take to get from our lowest value to our highest value, so to fade in. It could take a while to fade in, it could be a slow attack, or it could be a very fast attack. After that, we've got the decay. Now, the decay is the amount of time that it takes to go back down again. So, for example, we might have the note go, so it fades in and then comes back down again. That's the decay. After that, we've got the sustain. And the sustain is the amplitude that the note is held at. So if I've still got the key held down, what is the amplitude value that the note stays at for all the time that I've got the key then held down after the attack and the decay? And then finally, we've got the release. So when I let go of the key, what happens then? Does it immediately stop, or does it take a while to fade out? And that is an ADSR envelope. So let's make an ADSR envelope in this patch. So to do that, we can add a new object called ADSR tilde, ADSR envelope generator. So this ADSR envelope object is going to go between this amplitude value and this amplitude control. So we're going to connect this number up into the first inlet, which is the trigger. And then the outlet, which is the actual envelope, is going to go into the multiply signal object. And then we've got all of these inlets. So attack, decay, sustain, and release. So attack, decay, and release are all time-based values. It's milliseconds, okay? So it's how long it takes to fade in, how long it takes to fade back down again, how long it takes to die away. All of those values are in milliseconds. The sustain is a bit different. It's not a time-based value. Sustain is like, what is the percentage of the original amplitude that we should stay at when the note is held down? So that relates to amplitude. That's going to be a value between 0 and 1. So what we now want to add to this is some controls. We want some like sliders so that we can set the attack, decay, sustain, and release. If you go to the slider menu along the top, we're just going to use 4 of these sliders. Move a slider to output values. There are some other options here as well. There are dials and so forth. So you could use a dial instead if you want to, but I'm just going to use 4 of these. So before I make any other sliders, I'm just going to change some of the settings for this first slider. The range of this slider is between 0 and 127. A lot of the controls work like this. We've got this range of 0 up to 127, which is the same as the MIDI range. So 127 milliseconds, that's not much of a range. I want to increase the range. So I'm going to highlight the object, go over to the inspector. So that's this on the right where we've got like an eye. And then scrolling down, I want to change the range. So the minimum is 0, that's fine. But then I want the range to be like 2000 milliseconds. So that's like 2 seconds. And then I'm going to copy that. I'm going to have the same for decay. Same for release. But the middle one, this is sustain, this needs to be a value between 0 and 1. So these three, attack, decay, and release, can all be 0 to 2000, or you could increase that if you want to. And the sustain slider, the third one, that needs to be between 0 and 1. So that's the amplitude that the note sustains at. Now, in order to have a value between 0 and 1, we need to specify float output. So toggles floating point outputs from the slider object. The default is off. I need to turn that on. And then I will be able to set the range to 1. That gives us values between 0 and 1. So it's very important that you turn that on, otherwise you'll just get two values, 0 and 1. So next thing we can do then is to connect all of these up. And now we can try out our ADSR envelope. So let's set a like a mid attack decay. So let's just put everything around about the center, and then I'll press a key. Okay, so you can hear though what's happening. We've got attack, decay, the note is held at this amplitude, and then when I release the key, it fades away. Let's try it with a more exaggerated envelope. So I'm going to bring the sustain down, turn the release up. So now we've got all of these different options for shaping the amplitude of the note. I can have a short attack or no release. But notice that we still get that clicking sound if we do that, because we've got no transition between values. So if you want a very short attack, what I would do is just have this on a very low value. Similarly with release, I would just have it not at 0, but just at a low value. And that's going to stop it from clicking. If you don't want the note to sustain, so for example, if you just want it to die away straight away without sustaining as you hold the key, you can just turn sustain down. Okay, and I've got some release on there as well. There we go. Let's just tidy up the appearance of this a bit now. I'm going to make all of these a different colour. So let's see, background colour, let's change this colour scheme, royal colours, and then I'm going to have like a red for attack. There we go. Sustain. And release. You could also add a label if you want to. I mean, we'll keep changing the appearance of this as we go along and make it look nice, but you could add like a little label to each one, or maybe just a letter, ADSR. And maybe that's like that. So there we've got a playable keyboard. Now then, so the last thing I'm going to add to this in this video is something that lets us change the octave. So I've got my lowest note here set as 60. So I started off with 0 and I've just added 60 to that. So it counts up from 60 and that's our lowest note. But I might want to jump up higher than that or lower than that. I might want to jump up and down in terms of octave. On a conventional synthesizer, you've usually got like a transpose button that lets you shift up and down by an octave. We're going to add something like that to our keyboard, and we're just going to use the arrow keys, so the back key and the forwards key. So I'm going to get rid of this to make a bit of space. And then let's have a new object, key. And let's see what those keys are. So I'm going to press the back key, and it's 28, and then the forwards key, 29. So the two arrow keys on either side of up and down, 28 and 29. You can assign a different key if you want to. I'm going to use those two. So I want like a trigger attached to each of these keys. So I can make an object called cell or select output bangs based upon input matching, similar to root. And then I'll set 28 and 29 as my two values. So again, there we go, 28, 29, and then of course you get this other output if the input doesn't match. So what we want to do is to have an integer box in which the number 60 is stored. That's our default state. That's where we start. Okay, so that's the MIDI note number that we're going to start at as our lowest point. And we're going to jump up and down by increments of 12 whenever you press the back or the forward key. And that's going to move either down or up by an octave on either side of this value. So what we're going to need to do is to add to that value. And if we're pressing the back key, 28, it's going to add minus 12. And if we press the forwards key, 29, it's going to add 12. Okay, so add 12 to 60, that takes us up an octave to 72, fine. And then if we want to go down, it's add minus 12, which is the same as saying subtract 12, and that's going to take away 12, and that's going to take us down to the octave below. So we've got a value that's going to go into here, and then we're going to add either 12 or minus 12. Now, there's a particular order that we need to do this in. This number needs to go in first. That goes into what's called the cold inlet, which is always coloured blue. So this value here plus whatever the value is, that needs to go in first. And then it's only when a value goes into what's called the hot inlet, this red one, which triggers the calculation, that we'll get an output. So what we need to do is to set up two bangs in a particular sequence. And to do that, we can use an object called trigger, send an input to many places. So we're going to have this object trigger, and it's going to be trigger, bang, bang. So we've got two bangs, okay? And then this one on the right, that's going to happen first. And then this one on the left, that's going to happen second. So whenever this key gets pressed, 28, we get this bang, which hits the message. That sets minus 12 as our operand. And then this bang here is going to cause the output of the 60, which is stored in this integer box. And then that's going to pass out of the outlet. So let's try that. There we go, 60, 48. But the other thing that we need to do then is to have this value pass into the integer box. So it needs to overwrite the value which is being stored in this box, because that's going to mean that that value 48 is stored there, and when I press the key again, it goes down by another 12. Okay? So then we need to do the same thing over here. and then this number needs to go there. Let's tidy things up a little bit. Alright, so let's start at 60 and then go down an octave, down again, and then let's try going up. There we go, we've got a playable synth made from a computer keyboard. So in the next video, we'll look at adding some different types of oscillators. So at the moment, we've just got a sine oscillator. We'll add some others in the next video and look at getting some other classic synth sounds. So until then, take care and I'll see you next time.